Hey everybody, welcome back. Today we're going to be talking about chemistry and different types of bonds. So I'm sure that at some point in your schooling you have seen the periodic table of the elements. And I just have an example up here to review a few concepts. Now remember that elements are atoms that have characteristic structure and predictable chemical behavior. So for example, gold down here is shiny and metallic, and it's pretty malleable. You can bend it into different shapes and it's not brittle. It won't break when you try to bend it. Whereas helium up here is a gas and it's very sort of non-reactive and it's lighter than air, which is why when you want to make some pretty jewelry, you might make it out of gold because you can bend it and it won't break. Whereas if you wanted a balloon to float, you would fill it with helium. If you put gold in a balloon, it would not float. And you really wouldn't be able to bend helium and make it into a jewelry because it's a gas. So the elements are set out and laid out in order of their atomic number. And you can actually see the atomic number right up here. So hydrogen is number 1, helium is number 2, lithium is number 3, and so on, and they go across. The atomic number tells you the number of protons in each of these elements. An atom is the smallest amount of an element. So you can't have any less than 1 atom of gold, for example. You would have to break it apart and it wouldn't be gold anymore. And they are arranged by this atomic number, which increases as you go up in the periodic table of the elements. So something like hydrogen with atomic number 1 is going to have 1 proton. Something like phosphorus with an atomic number of 15 is going to have 15 protons. So we're going to use that information in a little while here. Remember that 1 atom is the smallest unit of an element. So you can't have anything less than 1 atom. This is 1 atom of oxygen, and that's all there is. If we wanted to put more than 1 atom together, we would have to stick them together somehow and form a molecule. The way we do that is to allow these atoms to form bonds. In order to understand how bonding works, we have to look at the subatomic particles of an atom and understand how they influence the atom's actions. Atoms are composed of a nucleus, which has the protons and neutrons in it, and an outer part, shells, where the electrons are. Now the protons and the neutrons are inside the nucleus. You can kind of look over here as a blown up version of the nucleus. Protons are positively charged. Neutrons don't have any charge to them, so I'm going to put a little 0 on them. Although they do not have a charge, they do have mass. So adding neutrons or subtracting neutrons from an atom actually changes its atomic mass, but not the atomic number. Electrons are shown outside here in the little blue balls. These have a negative charge to them. In a neutral atom, the number of protons, or positive charges, equals the number of negative charges. So for example, if you have something that has 7 protons, you should end up having 7 electrons because the number of positives have to equal the number of negatives in a neutral atom. So that's what neutral means. It means it's not positively charged, it's not negatively charged. It has no charge. Now this is somewhat messy to look at. You can't really tell how many or where the electrons are. And so we often, instead of drawing this type of thing, we draw an atom like this. So it's kind of flat. You can still see that the protons are inside the nucleus and the electrons are in shells outside the nucleus. And each of these shells is specific. As they get closer to the nucleus, they get smaller. So you can fit fewer electrons in them. And in fact, when we talk about electron shells, we're going to fill them from the inside to the outside. So in the first shell right here, number 1, it can only take 2 electrons. So we're going to put our first 2 electrons in there. The second shell can fit up to 8 electrons in it. Now, this particular atom is carbon, and carbon only has 6 electrons. So the first 2 go in the first shell, and then we only have 4 others. So even though we could put 8 electrons in the second shell, we don't have 8 electrons to put in there. So we arrange the ones that we have in the second shell. If this was an atom that had extra electrons and was bigger, and you filled up the first and second shell, you could actually move on to the third shell, which can take 8 electrons as well. Whatever the outermost shell is, in this case, this would be the outermost shell because it's the last one, that's what we call the valence shell. The octet rule states that the atoms like to have full shells. They are only fulfilled when their valence shells are full. In this example, carbon only has 4 electrons out of the possible 8 electrons that can fit in the outer valence shell. So carbon is not happy. This is why carbon tends to make bonds with other atoms. So how do we figure out whether the valence shell is full on any given atom, and therefore whether it would make bonds or not? Well, we go back to the periodic table of the elements. The way we know how many protons and electrons there are going to be is based on the atomic number. Remember, the atomic number is in the top left up here. So the atomic number tells you the number of protons in an element. You cannot change this number. So for example, hydrogen is atomic number 1. You can't add extra protons to hydrogen. So we're going to do some practicing. So helium is atomic number 2. And remember what we just talked about. The atomic number is the number of protons. So if the atomic number is 2, that means we have 2 protons. And we know that in a neutral atom, the number of positives have to equal the number of negatives. So if we have 2 protons, we know that we have 2 electrons. So go ahead and get out a pen and paper and draw along with me. I'm going to make the nucleus here, and I'm going to put my 2 protons inside the nucleus. Now, we're going to also draw the electrons. So I'm going to change color just so we can, let's do blue. And then the electrons, remember, go in a orbital or a shell around the nucleus. So there's my shell, and here's 1 electron, and here's another electron. So this is what helium would look like. We have 2 protons in the nucleus. We have 2 protons around, orbiting around it. Now remember, when we talked about our electron shells, we're going to fill from the inside to the outside, and each shell has a maximum number. So the first shell has a maximum number of 2 electrons. And that's in fact what we have in here because we only had 2 electrons. Now, does this element fulfill the octet rule? Remember, the first shell has to have 2 electrons. The second shell can have up to 8 electrons, and the third shell can also have up to 8 electrons. Because this is the first shell, it satisfies the octet rule because it has 2 electrons. So it's happy. Now helium, maybe you remember me saying, is very non-reactive. The reason it's not reactive is because it's completely fulfilled. It doesn't need another atom to help it fulfill the octet rule. And so it doesn't tend to bond with other atoms. So let's draw another one. Let's draw carbon. This time I want you to pause the video, get out a piece of paper, and try and draw carbon based on the fact that you know that since it's atomic number 6, it's going to have 6 protons, which means it's also going to have 6 electrons. So go ahead and draw that out and then come back. Welcome back. Hopefully your drawing looks something like mine. So what I did is I put my 6 protons in the nucleus, and then I drew my first electron shell, and I put 2 of my electrons in there. Now remember, I have 6 electrons. So once I've drawn my first shell, I have to draw another shell. And in that shell, I put the remaining 4. So does this guy fulfill the octet rule? No. Why does he not fulfill the octet rule? Well, because the octet rule says that to be happy, The valence shell, which is the outermost shell, has to have 2 electrons if it's the first shell, 8 electrons if it's the second shell. We only have 4 in here. So what's going to happen is that this guy is going to try to make some bonds to fulfill his octet rule, to fill himself up and get 8 in his outer shell. And so what's going to happen is this individual atom, which is carbon that we're going to talk about, is going to make some bonds and become a molecule simply to fulfill. The key points of this video is that the atomic number equals the number of protons. Once you know that, you can figure out the number of electrons, because in a neutral atom, protons equals electrons. When you are trying to figure out whether this atom will bond, you're going to add those electrons from the inner shell to the outer shell. And that outermost shell, the valence shell, is going to determine the reactivity, or whether this atom will bond with other atoms. Watch the next video to learn about the different types of bonds and how atoms form them. That's it for today. See you in class.